How's it, grade 10s? So we're going on to still solving right angle triangles, the second part. So with this example here, they've asked us to calculate to 1 decimal place. And just make a note there. And the first thing that they've asked us is to find this angle alpha. Okay, so from that given angle, I just want to find my opposite, adjacent, and hypotenuse. So immediately, straight off, opposite the 90 degrees, that's our hypotenuse. This here would be our adjacent. And this here would be our opposite. Now you can see the two given sides are this 4mm and the 11mm. So that is a combination of adjacent and hypotenuse. So the one that has the combination of adjacent and hypotenuse is cos. So we know that cos alpha would be equal to the adjacent side, which is DE, over the hypotenuse side, which is DF. Just fill in our values now. So we get cos alpha is equal to 4 over 11. Now you remember, how do we find an angle? We take our calculator, make sure that it's in degree mode, and we go shift cos to find the angle, to get rid of that cos there. And it is 4 over 11, close our bracket, and we get to 1 decimal place 68.7. 68.7 degrees. Okay, so that wasn't too bad. The next question is to solve for angle F. This angle over here. Now we know what this angle is, we know what this angle is, so we can work out this angle over here using angles in a triangle. So I know angle F would be equal to 180 degrees minus 90 minus 68.7, and our reason is angles of a triangle. Put that on the calculator and you will get 21.3 degrees. All right, so not too bad. Then example 2. Example 2 is saying determine the value of x over here, so it's an angle, correct to 1 decimal place. All right, so if we have a look at this angle x, which is in this triangle DBC, we only know one thing in that triangle, or two things if we look at it like this. We've got this angle, which is 90, and we've only got that side there. So we need another side in order to find that angle. And how I'm going to do it is I'm going to use this DBA triangle. I know what that side is, I know what that angle is. I can find out the length of this DB side using this information. Once I've got that DB, then I've got DB and I've got DC, we can find X. So in triangle ABD, in this triangle over here, with the given angle, which is this one here, just fill in your adjacent, opposite, and hypotenuse. So that will be our hypotenuse. This would be our adjacent. And this here would be our opposite. Okay, so we want to find this opposite side here. We have the hypotenuse. So which trig function has that combination of opposite hypotenuse? It'll be sine in triangle, sorry. So we know that DB over AD will be equal to sine 40 degrees. Okay, so let's get this DB on its own. So DB will be equal to AD times sine 40. So DB is equal to our AD is 14 times sine 40. dB is equal to, I'm going to put that on the calculator, and we get 14 times sine 40, and I can round that off to 2 decimal places, or 1 decimal place. So that's going to give us 10, bump that up, and that's going to give us a 9. Okay, so now we know what dB is, it's 9. Now what I'm going to do is I'm going to work in this DBC triangle. So in triangle DBC, I'm going to use another color now so you can see. This is the angle that we have. I'm going to fill in my adjacent, opposite, hypotenuse with respect to that yellow angle now. So this here would be our hypotenuse, this side here. This side here would be our adjacent. And this here would be our opposite. Okay, so if we have a look at the two sides that we know, we have an adjacent and a hypotenuse. Which trig function has that adjacent hypotenuse combination? It is cos. So we know that cos x will be equal to adjacent, which is DC, over the hypotenuse, which is dB. We can fill in our information now. So cos x is equal to DC is 8 over dB, which is 9. To get the x on its own, we go shift cos 8 over 9. And then we can round that off to 2 decimal places, and we get x is equal to 27.3 degrees. All right, so not too bad. Okay, grade 10s, I would like you to do exercise 5.7, numbers 1 and 2 for me, please. Thank you.